Now, go to your official note page for this, and here would just be a real random question. This might be a no calculator question. I would ask you, what is the sign of pi over 3? This is in radian mode, so the best thing to do, you don't have to sketch this one. Pi over 3, if it helps you, remember pi is 180 degrees, so we are talking about a 60-degree angle. A 60-degree angle sits approximately right here. Folks, here is the trick that I use. If this is 60 degrees, I think about how I would move it. I have to do my X movement and then my Y movement. I can clearly tell in this picture the up movement is a larger move. It's a bigger number. So you want to think about this. Any pi over 3 or pi over 6 always uses the square root of 3 over 2 and 1/2. But which comes first? On here, the number 1/2 is smaller than the square root of 3 over 2. So the smaller movement is here, therefore that has to be a half, and thus this has to be the square root of 3 over 2. The sign is the up or down movement, so the sign of this is the square root of 3 over 2. That's how you would use the unit circle to help you answer this question. Now this picture in front of you is a great sketch of the unit circle. Again, on the extra credit component, be careful though, I don't actually have you list this. What I need you to do is list that ordered pair. Tell me, for example, this is pi over 6, which is equivalent also to 30 degrees. And let me show you how we'll use this circle in the rest of the section. Okay, here's a great question. Find the exact value of the tangent of 30. All you need to do is go to 30 degrees. 30 degrees is right here. This is cosine and that is sine. If I'd asked you cosine or sine, that's incredibly easy to answer. But I want tangent. Remember, tangent is rise over run. So to graph this, this is my rise and that's my run. So by definition, the tangent of 30 degrees is equal to the sine of 30 over the cosine of 30. Look at your picture of this exact unit circle and plug it in. So what that gives us is our sine of 30 degrees, that is 1/2. Then we have the square root of 3 over 2. Now this is a complex fraction, which is a fraction in a fraction. The easiest way to deal with getting a fraction out of the bottom of one is just multiplying by its reciprocal. Do that on the bottom and do that on the top. Nice thing in doing that, this all goes away. What happens is we are left with, it's going to be 2 over 2 times the square root of 3. Now nice enough, the 2's cancel, we are left with 1's though. And so we are left with 1 over the square root of 3. Now we do have an issue. Again, no radicals in the denominator. To get rid of the radical in the denominator, multiply by the radical itself on the bottom and on the top. This leaves us with the square root of 3 over the square root of 9, which is just the number 3. That is the exact value for the tangent of 30. Now, if you use your calculator, by the way, and put that in there, it's going to give you a decimal answer, and that is not sufficient enough. You are required to show this amount of work when you have to find the exact values of a tangent. Here's another great example. They want you to find the tangent of 60 degrees. So what I would do is I go to my unit circle and I look for 60 degrees, which is about right here. You go back and look at your own picture. This is 1/2 and the square root of 3 over 2. Again, I want tangent, so it's sine over cosine. So the tangent of 60 is the sine of 60 degrees over the cosine of 60 degrees. Sine is the y movement, so that's square root of 3 over 2 and 1/2. Again, I have a complex fraction. To clean it up, just multiply by the reciprocal here. Do the same on the top. Nicely enough, this all cancels. And I'm left with 2 times the square root of 3 over 2. These 2's will cancel out, which is the same as 1 times the square root of 3 over 1, which is really the same as the square root of 3. So the final answer here is letter B, and this is enough work to be shown. Here's a quick review question from section 4.3. Which theorem verifies that the sine of 30, by the way, the sine of 30 degrees, if we look at 30 degrees, we were talking about that, the answer to that is 1/2. Is it equal to the cosine of 60? Cosine is the x movement. The cosine of 60 is 1/2. What theorem is that, folks? We mentioned it earlier. It's the complements theorem. Tells us that that is the case. Now I want to show you an example of how do you use the exact unit circle information to find answers in different quadrants other than quadrant 1. There's a nice connection. If you take a look at this, it says find the exact value of the cosine, sine, and tangent of 120. So basically what you would first do is identify where 120 degrees is on your circle, and they've done that right here. That's a 120 degree movement. Now the thing is, when you go to quadrant 2, 3, or 4, every angle will somehow track back to quadrant 1. Easiest way to do that is to look at the angle we drew of 120 and just go straight over and see what angle it aligns to. 120 has the exact same coordinate information as 60 degrees. Okay? If I were, by the way, to complete the circle, there's going to be two more angles that have the exact same coordinates. It's going to be this one, and it's going to be this one. What it ends up being is at 300 degrees. And then it's also going to be at 240 degrees. Now, all four of these components have the exact same 60 degree information. Well, what is it? 60 degree, this is 1/2, and it's the square root of 3 over 2. The only difference is it changes by sign. Now, to go into quadrant 2, I have to go not right and up, because in quadrant 1 I go right and up. In quadrant 2 I have to go left and up, so that means the x value changes. This is negative 1/2, square root of 3 over 2. Let me just show you another connection. What if I go to 240 degrees? Here I have to go left and down, so the only difference is the sign. To go left is negative, to go down is negative. And for 300 degrees, I would go right, so 1/2 is positive, but this time I go down, so this is 1/2 and negative square root of 3 over 2. This unit circle has tons of connections like this, and if you understand these connections, it's actually much easier to memorize this entire circle. Okay, let's answer the question. The cosine of 120 degrees, we've got it right here. It is negative 1/2. The sine of 120 is the square root of 3 over 2. Tangent by definition is sine over cosine. I'm going to do the square root of 3 over 2 and 1/2. We actually just did something like this. Let's get rid of this complex fraction real quickly. I'm actually going to get rid of these 2's right now, and I'm just left with the square root of 3. Okay, we're almost done. This is the second to last slide. What if I have you find it in radian mode? And I'm actually going, in this case, clockwise. I want the sine and cosine and tangent of negative 11/4 of a pi, or negative 11 pi over 4. What you need to do is first realize it's negative. So we are going clockwise with that. I need to move 11/4 of a pi. Where do I land on the unit circle is the big question. What I do is this. 11/4 is equal to, 4 goes in there evenly twice with remainder of 3. So it is 2 3/4 pi's. So I need to move negative 2 pi and then another 3/4 of a pi. So a negative 2 pi, there's negative 1, here's negative 2. 3/4 of a pi is going to land me right here. So this is exactly what they're talking about. Now this is a pi over 4. A pi over 4 is related to 45 degrees. You know, if I wanted to, again, I could make that connection, kind of connect all the way back like this. There's going to be 4 angles on the unit circle that all use the same pi over 4 relationship. If I go back over here, cosine and sine of pi over 4 is one of the easier ones. Square root of 2 over 2, square root of 2 over 2. So to get in quadrant 3, instead of going to the right and up, now I'm going to go to the left and down. So all it does is change the sign. To go left, that's a negative movement. To go down, that's a negative movement. Therefore, the cosine is negative square root of 2 over 2. The sine is negative square root of 2 over 2. The tangent is the slope of the line created by that angle. Here's the slope. By the way, the slope is positive. Okay, so we can tell, though, we're either going to have C or D be the right answer. This thing goes uphill, so it's going to have to be D. Let me prove it to you. Tangent is sine over cosine, so I'm going to take sine, divide it by cosine. Folks, this is the same number divided by the same number, which is the number 1. So the correct answer here is C, is the sine, the cosine, and the tangent. All right, I want you to try this last slide on your own. So pause the video, see if you can do it, and then turn the video back on and see if you have the correct answers. When you turn the video back on, all 3 answers will be there. If you need the explanation, listen. If not, you're done with the notes. So pause the video and try these 3 problems. Okay, here are the 3 answers. If you didn't get them, listen up. Let's look at the red. Find pi over 4. That's the same as 45 degrees. Sine is the y movement, so it's the square root of 2 over 2 is the answer. B, the cosines, they want the x value of 5/6 of a pi. Remember the unit circle, you can chunk, you want 5/6 of a pi. This thing can be chunked into 6 pieces. So 6 pieces of pi, right? Here's 1, 2, 3, 4. Here's my 6th piece of pi, which lands me right there. It lands me at 150 degrees. I then look back and I drew a line straight backwards to realize 150 degrees is the same as the 30-degree combination. So the only thing difference is the sign, and let me change it. It should be negative right here. Caught myself. The cosine is negative. The original cosine of 30 degrees is a right movement, square root of 3 over 2. Here I have to go back, so I go negative square root of 3 over 2. Part C, find the tangent of pi. Pi is a half of a circle, or 180 degrees, and it's going to land me right here. Definition of tangent is sine over cosine, so it's 0 over this negative 1. That is 0. A slope of 0 is what it means. The slope of 0 is a line that is flat with the horizon. We will do an entrance card in class to see if you get modified for this homework, so good luck to you.